So for this review, I was asked to talk about reorder points and safety stock, and those are related. You can have a reorder point without a safety stock, or you can have a reorder point that includes a safety stock. If there's no variability in either lead time or daily demand, then reorder point is simply daily demand times lead time in days. So that's pretty simple, very easy, very straightforward. Lead time is 5 days and daily demand is 100 units per day. And reorder point is equal to 5 times 100 equals 500. Reorder point is the inventory level at which you reorder, right? So if there's no variability, if you have 500 units left, it takes 5 days to get something, then you use 100. You use 100 units a day. You have 5 days till your next order comes in. When your inventory hits 500, you order again. So reorder point is exactly what it sounds like. It is the point of inventory at which you reorder. The EOQ is how much you order. That's an important distinction. So let's talk about it a little bit more. With uncertainty, we add safety stock. And the point of safety stock is to give you a little bit of a buffer to reduce the risk of running out before your order comes in. So if there's uncertainty with respect to lead time, or there's uncertainty with respect to daily demand, you may choose to build some buffer stock, some safety stock that reduces the risk of running out from the point you order. So let's talk about how that. So safety stock is equal to Z, which is just the standard normal, deviate, and you choose Z based on the likelihood of you running out that you choose, times the standard deviation of demand over lead time. So this is a number that is the standard deviation or represents the uncertainty associated with your lead time. So there are a couple of things. If only demand is variable, which means, and you can tell that by, you'll get a mean and a standard deviation. So if there's a mean demand and a standard deviation of demand, and then just a constant lead time, that's what this scenario is. In that circumstance, the standard deviation of demand over lead time is equal to the square root of lead time times the standard deviation of demand. So that's how you would figure it out. So there are three different ones. So if demand is constant, but lead time is variable, and I should have said it up here, lead time constant, So if demand is constant but lead time is variable, then the standard deviation of demand over lead time is equal to demand times the standard deviation of lead time. So that's an easy formula. And then the last case, if both demand and lead time are variable, standard deviation of demand over lead time is equal to the square root excuse me, of lead time times the variance of demand plus demand squared times the variance of lead time. So there are three different approaches to safety stock depending on where the variability comes from. So let's go through a couple of examples here. So we have a situation where average daily demand is 15 with a standard deviation of 5 and lead time is constant at 2 days. Find the reorder point if management wants a 90% service level. And the service level means the probability of having product when someone comes in. So the inverse of it is 10%, which is the probability that you won't have product or that you'll run out before your new order comes in. So the higher the service level is, the lower the probability you don't have anything. So as you can imagine, the higher the service level is, the higher your safety stock is. So we know that D is equal to 15. We know that standard deviation of D is equal to 5. We know that L is equal to 2. And we know that service level is 90%. So what do we have to do? We go to the standard normal table and 90% Z is equal to 1.28. Then standard deviation of demand over lead time is equal to the standard deviation of demand times the square root of lead time. So that's the formula from that last page that we just did. So then that the reorder point is equal to D times L, in this case average, plus 1.28 from up there times 5 times the square root of 2. So this is the safety stock amount. So you can do that, just do that math if you want. And this will be 15 times 2. So that's 30, the average, and this is the safety stock to account for the variability. So it's equal to 30 plus 9.02, which is the safety stock, which is approximately equal to 39. So that's how you would, reorder point is 39, safety stock is 9.02. So let's go through a different example now. Daily demand is equal to 10, constant. Lead time is normally distributed with mean 6 and standard deviation of 3. You want a 98% service level. So, standard normal table, you get Z is equal to 2.055, and the solution is reorder point is equal to D times L plus 2.055 times the standard deviation, which was 3 times D, which was, this is variance of lead time times D, which is the formula that we use. Which would be equal to 10 times 6 plus 2.055 times 3 times 10. Equals 60 plus 61.65. Safety stock is equal to 121.65, 122. Okay, so that's if demand is constant but lead time varies. The first one I showed you was demand is variable but lead time is constant. Let's look at what if both of them are variable. So you've got D is equal to 150 with a standard deviation of 16. L is equal to 5 with standard deviation is 1, and you want a 95% service level. So if you were reading a question, you would look, if there's a standard deviation, you know it's variable. In this case, you have two standard deviations so that they're both variable. If you were doing something different, you might, if it was 150 with 5 with a standard deviation of 1, then it would just be one of them variable. So that's the way you tell the difference between which one you choose. So Z is equal to 1.65 from the standard normal table. Reorder point is equal to D times L plus 1.65 times the standard deviation of demand over lead time equals 150 times 5 plus 1.65 times the square root of 5, which is that, times 16 squared, because that's a standard deviation, you have to make it into a variance, plus 22.5, plus 150 squared times 1 squared, which is the standard deviation, is equal to 750 plus safety stock of 254. So the reorder point, that's safety stock, the reorder point is 1004. So really the only thing that differs here, you always do D times L plus the Z value times that standard deviation of demand over lead time. There are just 3 different ways to calculate demand over lead time. So reorder point, relatively straightforward. It is the point at which you place an order. The economic order quantity is the quantity that you order when you place an order. And if there's variability, you will have safety stock. The safety stock will vary based on what your service level is or what the probability is that you want to have, that you'll have product for everyone who walks in. And you calculate the safety stock using the standard deviation of demand over lead time that varies depending on which elements are variable. So that is the last of the 3 inventory reviews. If you have any questions, please let me know.